All right. Hi, everybody. How's everybody doing? You're good? Good coffee break? All right. I love this venue. I just realized that we are right now on a bridge over a bridge. So it's like double bridge right here. It's different layers of abstraction. It's very, very cool. So like Tim mentioned, my name is John. I run Swift by Sundell, which is a series of weekly articles and a podcast about Swift development. But most importantly is that I'm a Swift developer, just like you. And I really, really love Swift. And being here today to see so many people excited about Swift on the server is just really, really heartwarming. My topic, though, is not going to be strictly about server-side Swift, but rather about static site generation and how we can utilize Swift as a fantastic language to statically generate really, really powerful and fast websites. So over the last couple of months, or the last half year, I should say, I've been hard at work building the new version of my website, Swift by Sundell 2.0. I just launched it about 2 months ago, and I've been really, really blown away by the amazing reception from the Swift community about this site. I tried to make it as absolutely fast as I could be, and I tried to make it as easy to navigate as well, with lots of new features, instant search, and a lot of the better structure and overview of the site's content. However, the feature that I'm the absolute most proud of, you have to scroll all the way down to the bottom of the page. You have to look at this little footer there at the bottom. So we're going to zoom in on it a little bit here. You can see that it says, generated using JavaScript, or not using JavaScript, generated using Swift, 100% JavaScript free. That's very cool, right? Yeah. So this is something that has been creating a lot of questions in the community. I actually get multiple emails every day about this footer. It's like, what does it mean? What does it mean that it's generated using using Swift? And what does it mean that it's JavaScript free? Can you even build a website these days that is JavaScript free? Well, it turns out that you can. So let's talk about that. But first, let's start at the very beginning and talk about I'm just going to switch over here so I can see there we go. Let's talk about what is actually static site generation to begin with. It's a topic that some of you might be familiar with, but some of you might not. So I think that websites in general can be divided into 3 main categories in terms of their high-level architecture. So we can start with what I like to call the classic web. It's kind of like how websites were built in the early days of the web, where servers and clients are communicating over HTML. So clients are sending requests, the server processes that requests, and send HTML back, which the client then renders. So in this kind of architecture and the style of web development, the server is really the brains behind the operation. It contains all of the logic, and it really just serves HTML that the client can just render immediately. So the client is just a renderer in this kind of architecture. And this server can be written in, of course, in any language, including Swift, which is really cool. But these days, I would say most more complex websites have moved to a slightly different architecture that looks more like this, like to call the modern web. And here, JavaScript is a very, very important part, where the server sends a JavaScript program that the client then executes and talks to the server asynchronously throughout the lifecycle of the website. So here, the client is really where most of the logic lies. It's kind of very similar to if you've done native app development for example, iOS or Android or the Mac, where your server is not really like generating HTML. It's more acting as an API, as a data store, where the logic is in the client, it's communicating, getting JSON back, and then constructing the HTML client side, for example, using frameworks like React or Vue.js, etc. Now, static sites is a bit of an alternative to both of these two things. On the surface level, it looks very, very similar to the classic web. We're still serving HTML from a server. That's kind of what you need to do. And we still have clients, of course. However, there's no real logic here. So that might seem a little bit strange. But if there's no logic on the server and there's no logic on the client, where's the logic? Like, who decides what the website will look like and what it will contain? Well, the key word really here is static, in that we are generating our website statically once and then serving it to our users. So how does that process look like? Well, usually it involves starting out with your content. It can be, for example, text files. It can be pre-rendered HTML also. It can be images, videos, etc., whatever you want to display on your site. You then run that content through a static site generator, which takes that input and it looks at the metadata, looks at the text files, it processes it, and it outputs HTML. That HTML is ready to be displayed on a website. It can be displayed on a local host server, and it can be uploaded to an actual cloud server where users can access it. Now, when the users access it, they get served that exact HTML that we generated statically. And this process can happen either on a local machine as part of your development process, or it can also happen, for example, on your CI system or on a server as well. So there's a lot of different ways to use it. But the key part here really is that that HTML that we once generated, that is served to every user. Now there's of course some kind of exceptions and caveats here. You could customize things, but in general, that's what static site generation is all about. And that of course has pros and cons, just like everything else. It's not a silver bullet, but it does have some nice applications and also some downsides. So let's take a look at those. The pros is that, well, the most obvious one is that we don't need to process any requests dynamically. There's no need to write any code to process each request and to run some kind of logic. The HTML is already ready to be served. That makes things extremely scalable, because you don't need to worry about CPU usage or memory usage as much as you would if you have a dynamic server. You can simply just return the HTML that you need to return. It can be done by any web server that ever existed. That makes things also very, very cache-friendly, because since every user gets the same HTML, we can cache that centrally, for example, on a content delivery network, a CDN, and easily serve that continuously as a cached version, which can make things extremely, extremely fast, which is really cool. I love fast software. All right, so what are some of the cons? Again, it's not a silver bullet. It's not a replacement for ServerSide.swift or any other server-side mechanism. The cons are, of course, that we can't tailor the content for each user, and we can't have so many dynamic features. I wouldn't want to build an advanced service or a banking application or anything that has user login using static site generation. It just wouldn't make sense. The same thing is true for caching, where if we are heavily caching things, that could, if we're not careful, lead to some stale content being served. We need to make sure to invalidate our cache whenever we're regenerating our website. And speaking of which, that's something we have to do every single time we make a change, which could add some overhead to our overall process. We can't just upload something in a CMS and it's all just working. We have to regenerate and re-upload the website. So again, it's not a silver bullet, and I also believe that there's a lot of opportunities to combine static site generation with server-side.swift, where you can have some of your endpoints statically generated and some of them dynamically generated, depending on what you need. But the real million-dollar question here, of course, in this talk is, why should we use Swift for static site generation? After all, there's so many different static site generators already out there, and they're great. They're used by many, many people, powering a lot of websites around the web. So why build yet another one, and why use Swift for that? Well, if you look at the overall landscape of the static site generators that are currently available, they are mainly written in 3 different languages: JavaScript, Ruby, and Python. Now, I like these languages. With my 100% JavaScript free, it might seem that I don't like JavaScript, but I kind of like these languages. They have different great applications and use cases. But of course, they are all dynamic. We know this. Like, they are dynamic languages, they are dynamically typed, they are very, very runtime heavy. And Swift, on the other hand, is quite the opposite. It's a quite static language. It has lots of build time features. So it might seem like a pretty big departure from what the overall static site generation community is using right now. So when we're examining why to use Swift for static site generation, I think it's very, very similar to the question people are asking around why use Swift for server-side development. After all, like, the reason we like Swift for doing server-side development is so many of the same things that would make it good for other use cases as well. Things like that Swift is fast and it's efficient. We can compile it down into binary code and deploy that. It has a static type system that checks our code much more thoroughly at build time so that it's less prone to runtime errors. But at the same time, it's not only a static language, it also has modern features. It has things like type inference, it has first-class functions and generics and all that good stuff that we really like. But perhaps the best part, and one of my favorite features of Swift, is how extensible it is. You can take the integer type from the standard library and add your own methods to it. How cool isn't that? It also has a great and powerful module system where we can use the Swift package manager to bring in third-party code, and we can really plug and play and modularize our code, which is really, really awesome. So these are some of the reasons why we want to use Swift on the server, which you probably already know. But I think the same things are also true for static site generation as well. We want our static sites to be fast to generate because we're going to do it quite a lot. We also want to use a static type system because that's going to make our code less prone to runtime errors. And by using modern features, we can build DSLs and lots of cool features that enables us to build things much, much quicker. But there's another thing about using Swift for static site generation in particular that I think is really interesting. So I mentioned earlier that the majority of the languages used today to do this task are very, very runtime focused. They're dynamically typed, they run at runtime, and they interact mostly during the runtime as well. But Swift, on the other hand, has this other phase, the build time, where we can verify so much more of our code before it has even run. And what's interesting here in this context is that the build time and the runtime, they're kind of happening at the same time. You are not running the program every time a user accesses the site anymore. You're just running it once and then uploading the result. So the runtime kind of becomes an extension of the build time, which gives us some really powerful capabilities. Let's take a look at one of those. Let's say that we want to verify the contents of an array. Let's say that we're building a blogging engine that we want to build using static site generation. And that we had this blog post array, which the compiler will make sure that we have used the correct type of that, and that the correct type of elements are stored in that array. So if you have an array of blog posts, we cannot put strings in there, we cannot put integers in there. It's all statically verified by the compiler. But then, at runtime, when we're actually generating our site, we can verify the contents of that array. For example, we can make sure it has the correct count, and we can make sure that all the elements satisfy a given condition. For example, we can do something like this. We can use the all-satisfy API, which is part of standard library, and we can make sure that all of our blog posts have tags, or else we can throw an error. That's super useful, as it allows us to validate our content before we've even deployed it, which reduces the likelihood of bugs. So these are some examples of why you might want to use static site generation and why we might want to use Swift in particular for it. But that's just, of course, one part of the puzzle. The biggest part of the puzzle is how to actually build it. How to build a static site generator is kind of a tongue twister in Swift. Well, with any static site generator, you really have 3 different phases that you need to go through, 3 different tasks that you need to accomplish. The first thing that we need to do is that we need to read our content files, those text files and images and all the other content that we want to display on our website. The second thing we need to do is we need to parse that content somehow. We need to identify the metadata, and we need to create some kind of structural representation of it that we can then use in order to generate our site. And that's the third task, to actually take that information, apply some form of templates to it to generate HTML. So I want to show you 2 implementations of a static site generator today. I should just come up with a shortcut for it. And the first thing I want to show you is a basic implementation of a statically generated blog. So let's say that we wanted to write a blog engine, like something that enables us to write blog posts, run a tool, a static site generator, and then upload that HTML to our server. So the first thing, like I mentioned, we need to do is to read our content files. Whenever we are dealing with content this way, it's usually good to establish some form of conventions. You don't want the content to just be able to be anything, because that would make the generator extremely complex. You would need to handle all different kind of cases. So common conventions that are established by many other tools as well is what text format to use and what kind of folder structure to use. So for the text format, let's use Markdown. Markdown is something that most of you are probably familiar with. It's a text format created by John Gruber, which is really, really nice to use, as it lets you both identify the structure of your different text segments, and it also lets you inline HTML whenever you need that as well. But one thing you might notice here in this Markdown example here is this top part, the metadata. This is something that is not really formally part of the Markdown spec, but it's something that most static site generators have added, and other tools as well, in order to be able to define metadata in line in the Markdown document, which is really useful since it enables us to define the date, the publishing date, the different tags of this post, and so on and so forth. And the other important part here is, of course, the folder structure. We don't, again, want to enable any folder structure at all, because that would be very complicated. So we're saying that we're going to have a root folder, and in that root folder, we're going to have two key folders. The first one is for all of our posts. It's just going to contain all of our Markdown files. And then we're going to have another folder for our templates. We're going to have a post.html template that we use to generate our content. All right, so that's our conventions. Now let's actually start writing some code. The first thing I'm going to do is I'm going to import a library called Files. This is a library that I built, which is available on GitHub. It's open source. It's been out there for a few years now, and it was recently updated with a brand new Swifty API for the latest versions of Swift. What it enables you to do is to get a more object-oriented API around files, which is really nice. It also works great on the server as well. So I'm going to go ahead here and get the subfolder named posts, like we just saw in our conventions. So I'm going to get a reference to that folder, and then I'm going to create a temporary array that contains all of my posts that I'm going to process now. To do that, let's iterate over all of the files within our posts folder. We get the markdown by reading the file as a string. And then we pass that markdown into a makePost function, which is going to actually do the parsing and return a post value. We then take that post value and append it to our array. This function here is what we're going to use to parse each file. And we're going to take a look at that in just a second. And then finally, we're going to generate our HTML based on those posts. This is really all the file I/O you need to do in order to do this kind of basic static site generation, which I think is pretty cool. But, of course, this is just the beginning. So the second task that we need to perform is to actually parse our content. To parse our content, we need to first establish a good format or a good data structure that we're going to use to represent it. We're going to use a quite simple one here. We're going to call it post. It's just going to have three properties, one for title, one for the body of the markdown, and then one for the metadata associated with that post. For the metadata, we're going to just create a nested structure which contains the date and the tags, the metadata that we saw earlier. So this is what we're going to parse right now. Let's do that by implementing the makePost function. Like we saw earlier, it takes a markdown string, and its job is to parse that into a post struct. To do that, we're going to start by splitting up the markdown by those three dashes that we saw earlier that defines the metadata. Now, this is not the most efficient way of doing things, but let's just do it to get started. Hopefully, we will get three different segments or components from this API call. We'll get one which is just empty at the top, we'll get one that contains the metadata, and then we will get one component that contains the rest of the page. We're going to make sure that we have those three components, or otherwise we're going to say that this markdown was in fact invalid. Next, what we're going to do is we're going to parse out the metadata from that second segment. And we're going to parse out the body from the third segment. And then finally call a function that extracts the title from that body segment. I'm not going to go into details around those string parsing functions, because it's kind of your run-to-the-mill string parsing, where you're looking through and identifying certain characters that you want to parse out, and then returning the results. And then finally, we're going to return a post value with the title, the body, and the metadata that we just parsed out. So now we have an array of posts and our structured representation of our content. The third and final thing that we need to do is to actually generate our HTML. To do that, we're going to implement yet another function. This one is going to be our most complex yet, but still it fits on a single slide. And to do that, we're going to take our array of post values that we just parsed, and we're going to start by getting a template. I mentioned earlier that our convention was to have a templates folder and then to have a post.html template within that folder. So we're going to read that as a string, and that's going to be our HTML template. Then we're going to create a folder for our output, where we're actually going to put the HTML files that we ended up generating in an output folder. And then we need to sort through our posts. And to do that, we're going to sort by the metadata date key path, so that we get all the latest posts on top, so that we can just make a nice little list of them. Now, to actually do our filling in of our template in order to be able to generate our final HTML, we're going to start by formatting our markdown into HTML. To do this, you can use a number of different open source projects that are available, for example, CommonMark, and I have also built an implementation as well that I will show you in just a bit. We're going to take that content then and string replace into our template, for example, certain tokens like title, content, date, and so on. Again, this is definitely not the most efficient way of doing things, but it gets the job done as a starting point. And then finally, once we have our final HTML, we're going to create a subfolder within our output folder, and we're going to save that folder using the post name, and then create an index.html file within that folder containing our HTML. So this way, when a user goes to our website / the name of our post, they're going to see that index.html file in their browser, which is pretty cool. And that's really all we need to do to create a basic, simple implementation of a static site generator. And I mentioned a few times now that it's not the most efficient one or the most elegant one. It has a lot of problems, and we probably don't want to do this kind of string replacement here. It's kind of a little bit error-prone. However, it is a starting point. And in fact, this is pretty much the exact way that I generated my first static website that I released this summer called WWDC by Sundell. This was a week-long website. It's still up, but I'm no longer posting on it, where I was covering Apple's WWDC conference in San Jose. Now, this was generated using that very, very simple approach that we just saw. And you might think, well, is that really something you could scale and something that could work? Well, it worked really well. In fact, during that week, I published over 30 different articles, all using this methodology. I also had an RSS feed, podcast feed, images, and so much more, all generated using this same technique. And the website worked wonderfully. It had over 100,000 visitors during the WWDC week alone, and it handled over 2.5 million requests, again, using that very simple approach that we just saw. So there's no shame in starting out simple. Definitely not. Start out simple, build something, and ship it, and then see how things goes. But of course, that was just the beginning. And I've been hard at work since WWDC with a new version of my static site generator, which is powering that new version of Swift by Sundell that we saw earlier. It's written using a lot more advanced features, and it has more capabilities that enable me to scale my writing and my podcasting and all of my content creation and put it all on one site. And the key part here really for me was that I really wanted to take full advantage of all of Swift's powerful features to enable me to be more productive and to create a website that was more stable and less prone to errors. So some examples of what I did in order to do that. The first thing that I started by doing is to embrace protocol-oriented programming. It's something that most Swift developers are familiar with, to use protocols to define your requirements, to define your types, which enables you to gain a much greater degree of flexibility. In my case, I started out with a website protocol. This website protocol really defines a website that we're going to generate. It's no longer just tied to being a blog, but it can be really any website that has sections. It can have some custom item metadata. It can have a URL, name, and description. And the important part here, or the key part, is that I use the type system to enable users of the static site generator to customize it. So you can define your own sections that your website will contain. For example, you might have posts, or contact me, or my resume, or if you're a restaurant, you might have the menu, or make a reservation, whatever different sections that your website contains. And then your item metadata can also be completely customized, since it's just an associated type. And also what's important here is that the implementation of these properties that you see here can be implemented however the user wants. You don't need to conform to some specific JSON format or something like this. You can decide how to return that information. For example, you might use a different URL for staging and for production. So now that we have this protocol, which is a quite simple protocol, it just has a few requirements, but it gives us a lot of power in terms of building really nice APIs that take advantage of this type information in order to do some cool things. So a few examples. Here is a function that enables us to sort all the items within a given section based on a key path. We can do this using generics. This might look a little bit complicated in terms of how the function is defined. It takes a website type, it takes a comparable value that we want to compare against, and then it takes that section and that key path. But look at the call sites. Sort items in articles based on date. That is really nice. So by using those advanced generics features, we can actually build very simple and easy to use elegant APIs that almost look like English sentences. You can just read it out loud, which is really cool. And here we're making use of that site-specific ID that we just saw before, so that you're no longer bound to a specific set of sections. You can define your very own. So articles in this case is not hard-coded in the static site generator. It's something that the user supplied. Let's take a look at another example. Here we're mutating all the items within a given section. So we're calling this function mutate items in the podcast section in this case. We get the item in, which is a representation of that page or of that item, that content item. We're then unwrapping its audio URL, which is again is a site-specific metadata. Audio URL is not part of the static site generation process. It's something that is specifically defined for this website, which has a podcast. And then we're calling this item prepend HTML, and we can just say .audio player for URL. And that's because we have now a type-safe HTML DSL, which enables us to express HTML as Swift values and Swift objects, which really improves type safety, and it gets away with all of that string parsing and string replacement that we saw earlier. Another example is how we actually construct those HTML nodes. So here we have an extension on the node type, which is a part of the HTML DSL, where the context that we're currently operating in is the HTML body context. So this node here can be placed within the body of an HTML page. It's context aware. We've defined a static function here for a tag list for a given item. So it passes in an item. In this case, it's a Swift by Sundell item, but it can be for any website, and it returns a node. And here's what that looks like. You simply type out Swift code as if it was HTML. You can use UL and LI. You can use for each struct. You get each tag in, and then you can return an anchor tag with a specific href and a specific text. It looks like HTML, but it's 100% type safe. And we've got element-specific attributes so that I can type .href here within the A tag, but I can't put it inside of any other tag that doesn't support hrefs. So you get also Swift's compiler helping you out to validate your HTML before you've even deployed your site, which is super cool. So now that we have these building blocks, we have the DSL, we have the APIs, we have all that stuff, we can build some really sophisticated pipelines. This is, in fact, the exact pipeline that I use to generate Swift by Sundell. It has quite a lot of steps. It has Splash for syntax highlighting, it verifies lots of things, it creates different standalone pages and podcast feeds and all different things. However, I didn't want anybody to have to write all of this code in order to generate a website. That would be kind of tedious. So since we have so much information in the type system, the static site generator is able to infer so much information just from that protocol alone that all you have to do to get started is to just use one line of code to create an instance of your website that conforms to that protocol we saw earlier and generate it using a given theme. That's pretty cool. So all of this boils down to not just one tool that I've been building, but 3 tools, in fact. The first one is called Ink. It's a fast, simple, and accurate Markdown HTML formatter, which operates at nearly O of n speed in terms of complexity. So it just reads through each Markdown file once, which is really hard to pull off. And it's not completely O of n, but it's almost getting there. The second tool is called Plot. It's a powerful Swift HTML DSL for defining robust templates in Swift with 100% type safety. And this all comes together into Publish, which is a static site generator built specifically for Swift developers. And since this is Halloween, and on Halloween you're supposed to do scary things, so what I want to do now is show you the very, very first ever live demo of Publish running live. You want to see it? All right. So let's jump over to here. So here's my general development setup. I've got Xcode on the left, and I've got Chrome on the right. What we're going to do here is we're going to want to add a little promotion for our conference that we're at on Swift by Sundell. Wouldn't that be cool? So here we've got Swift by Sundell running on localhost, and I'm going to go ahead here and navigate into an article. And what we want to do here is add a promotion here right at the top. We could, of course, modify our templates in order to do this, but that wouldn't really be great, because we would start having to always modify the template every time we want to do something temporary. So let's write a plugin instead. To do that, I'm going to extend the generation step type. Is this big enough, by the way? Can you see it? Yeah? OK. I'm going to extend the generation step type where the site we're operating on is, in fact, Swift by Sundell. And I'm going to create a static function here, which is called add ServerSide.swift promotion. And it's going to return a generation step. To do that, we're going to return the mutate items in step. And we're going to mutate all the items that are within the articles section. Again, you can see here we get autocomplete in Xcode. We don't have to use YAML files or JSON or something. It's Swift code that is completely valid Swift code. So we can mutate all the items in the article section, and we're going to do that using a closure, where we get an item that comes into this closure. To mutate it, we're going to add some HTML to this article that we want to display. So to do that, I'm going to say item, prepend HTML, and here I'm going to pass in a node. And this node here can be any HTML node that fits within a body of an HTML page. For example, an anchor tag. The anchor tag then has a bunch of different nodes or attributes inside of it. For example, href, like we saw earlier. So that can be server HTTPS. It's important to have security, right? ServerSide.swift.info. And then we can add some text to this anchor tag as well. So we can just say, check out ServerSide.swift. It's awesome. Because it is awesome. Don't you agree? I think it's awesome. All right, so that's now our HTML that we prepended. Let's now go ahead and add this generation step into our pipeline. So I'm going to jump over to main.swift here, where you see the pipeline for generating Swift by Sundell. And just before I generate my HTML, I'm just going to add my new plugin here, add ServerSide.swift promotion. And as you can see here, it fits right into all of the native generation steps that come as part of the generator. It just looks like it. All right, let's now run our static site generator. It's going to compile our code, build it, and run it. And then you see automatically here, we get our new A tag right there up in the top of the page. Pretty cool, right? All right, so that's a nice like hello world, but it doesn't look very great. It doesn't look like a promotion. It's just text, right? So let's make it look a little bit nicer. I'm going to wrap this into a div. So I'm going to create a div here. And then I'm going to add a class to that div by saying that I want to use the class name promotion. Let's run that again. So now we've wrapped that into a div tag with the class promotion, and it already looks nicer. And as you can see here, we have hot reloading, where we can just write our Swift code, run the program, and it automatically updates Chrome, which is a very, very nice development experience. But it still looks kind of, it can draw a little bit better attention to itself. So let's wrap this A tag in an H2 tag instead to make the text a little bit bigger. So H2, for those of you who are not HTML familiar, it's the second level of header on the page. So it's going to be a much, much bigger text. So let's run again. And now, now it's starting to look like something. We've got nice text there. It's really screaming out that Server-Side.swift is awesome. All right, but we can do one more thing. Let's add a little image as well to this promotion. So right here before the H2 tag, I'm going to add an img tag, which is an image in HTML. And img, of course, is defined using the source. So it's src in HTML terms. And this takes a URL. So I'm going to use a local URL here, which is images/server-side-swift.png. And we can run the program again. And we've got, look at that. Isn't that nice? That's a nice promotion, I think. All right. So this is, of course, a very simple demo, but I think it just shows you the power of static site generation in that I was able in just a few minutes to fundamentally change this page. And since I implemented it as a plugin, it's visible in all the different articles, so I can navigate through different articles, and the promotion is visible in all of them, because I've added that as a prepend operation to each item. So that's just a very quick glimpse at how cool it is to use Swift to define HTML, and how nice it is to have a plugin architecture where you can just plug in new generation steps and add new content to your website. All right, let's go back to the slides and wrap things up. Oh, there we go. Play. All right, so I've been really hard at work on these tools, on the new version of Swift by Sundell, and I love to share things with the community. So I'm very happy to let you know that all of these tools you've seen today, Inc., Plot, and Publish, will be open sourced before the end of the year, so that everybody will be able to use them completely free and open source. And that's all I had for you. I hope you enjoyed this talk, and I'm looking forward to talk to more of you throughout this conference as well. So thank you so much.